Okay, today's video is on equivalent expressions. This is going to lead into a lot of solving equations. And first question, of course, is why? Why would we want to write equivalent expressions? Well, let me give you a couple quick examples. First equation, y equals x squared minus 9. Find the x-intercepts. I can very quickly glance at that equation and tell you the y-intercept is -9. But x-intercepts, it's a lot easier to write an equivalent expression, which is y equals x plus 3 times x minus 3, which tells me that the x-intercepts are at 3, 0 and -3, 0. Let me give you another example. Y equals 2x squared plus 5x plus 2. Find the vertex. Now, I could find the x-intercepts, but of course I'd have to rewrite this as an equivalent expression to do that. Or I could write this in graphing form, as we talked about last chapter, which is x plus 1.25 squared minus 1.125. And immediately I know that the vertex is at -1.12, or excuse me, -1.25 comma -1.125. So equivalent expressions frequently allow us to solve a problem much more easily. We're going to see a lot more problems like that as we move along. Now, how do I prove that two things are equivalent? Well, here's the mathematical process that we follow. Manipulate one side, or manipulate one equation or expression until it looks like the other. So I'll give you a quick example. 3 times x minus 1 squared minus 5, is it equivalent to 3x squared minus 6x minus 2? Now, the temptation is to start doing things to both sides, add 5 to both sides, blah, blah, blah. But we're not actually going to do that. We're going to just focus on the left-hand side. And if I look at this, I could square x minus 1, and I get x squared minus 2x plus 1. Notice that is an equivalent expression to the first. Number 1 and number 2 are equivalent because I did a legal mathematical move. Next, distribute the 3. 3x squared minus 6x plus 3 minus 5. I've got another equivalent expression because I did a legal mathematical move. Finally, I'm going to combine like terms, minus 6x minus 2, which is a legal mathematical move. And what I now see is that these expressions are, in fact, equivalent.